So now, as we see on our screen here, we've got the overall scan of the overall Canon scan. So, but inevitably we're going to be missing some pieces of it that we can't scan, and I scanned this at a resolution that was only it's 0.5 millimeters, which is the maximum length of one of the polygonal sides, basically. So the smaller you make this number, the higher detail you can gather from this. It's neat. This is a great way to handle assemblies that you know you're going to be scanning individual parts, but you want to put them back into the same orientation that they were in the assembled form. So that's what I want to show you now. This is more of a tutorial video to talk about how to do that. So we roughly scan this again at 0.5 millimeter resolution or point density. And now what I'm going to do is actually disassemble this, and we're going to scan the barrel separate and the carriage separate. And then we could realign them in the software based on this scan that we scan with everything together. I'll take this thing apart. Interesting story. This, my father and I'm from Florida, from Jacksonville, Florida, and we took a trip down to St. Augustine, Florida. Whoa. We took a trip down to St. Augustine, Florida, went to the fort there. And they had a bunch of cannons, around the fort. Well, I was all excited about the cannons, and on our way home, I asked my dad. I said, "Hey, can we build a cannon?" And my dad, being my dad, said, "Sure, why not?" We would always, we build stuff together. We tinker in his shop and so forth. So we went home and found a piece of bar stock here, and on his lathe, which I actually have now, he gave it to me, his lathe that was built in 1870 something, we don't exactly know when, it's very old. Anyway, obviously it's been converted to electric and all that. Anyway, we built this cannon on his lathe and built the carriage and everything ourselves, so that was cool. This cannon, since then, it's been 30 something years old. It's been fired hundreds of times. Anyway, little aside. All right, so I've got this disassembled. So we've got the carriage and the barrel separate. So I'm going to let's start with the carriage. All right, so we're going to start a new scan. This time I'm going to set the point density down. Let's do 1.125. And we're going to do, as we know, for our best accuracy, we're going to do a marker point scan. Turntables are very nice because you can set up targets on the table itself. Obviously it makes it easy, so I don't have to try to orbit the part like this. I can kind of hold the scanner in generally the same area. So I definitely recommend you get a turntable. All right, so now we're going to make a clipping plane. There you go. Laser point. Checking my point density, that looks good. Scan. Any lower than this, as far as the resolution, the point density, or lower the number, higher the point density, at some point you're going to get to a point where you have to actually do what's called fine scan. This scanner has 3 different modes. This is crossing laser mode, so this is the fastest mode to scan with. I can scan at this resolution, I can scan the entire thing with this mode. However, just to show you, so crossing lasers here. If I double click this, I'll get parallel line lasers. This is for smaller detail, for higher resolution scanning. The caveat to this is you have to be closer to your object, so you have to have higher density of targets to be able to pick up 4 at all times while you're scanning. So, and like I said, this is right at the edge where I would actually probably just use the multi crossing lasers. but I wanted to show you that it does have this other mode. And it has a third mode, which is single line laser. So literally a single line here. And this line is optimally placed geometrically relative to the cameras to get deep into holes. So that's what it's really for. It actually has the same depth of field as the crossing laser. So I don't have to be close. I could be at the same distance like I would a crossing laser. But again, this is for deeper holes, deeper crevices, slots, or whatever. For this, it's not really that applicable, but I wanted to show that to you anyway, that we have that. So you got to be a little judicious with how you use this because it can introduce other noise into the scan, a little bit more noise. But in general, it works great, like I said, to get down deep into crevices and holes. All right. So I feel like I've scanned this pretty thoroughly. We'll get some more on the other side in a second. You notice it's taking a little longer because we have a lot more, we've collected a lot more data. Because we have our point density set a lot finer in this case. This is another great example, a little tidbit here, just definitely use a clipping plane, especially when you have very high resolution, because now you're not having to process all this data that is the table that you're going to delete anyway, because it has to process everything that it sees in its scene. It doesn't know that this is what you want. It knows, it just sees what it sees. So if you go ahead and put that clipping plane in there, you're going to reduce the amount of data so that it has to work with. So that's a good thing. All right, turn this off. That looks fine. Okay, now we're going to flip the part here. I'm going to check, I always check my point density. Looks good. Do a marker point scan. Okay, since I already scanned it from the other side, I don't have to concentrate as much on the sides, for instance, because I've already got a lot of that data. So I'm concentrating, I'm looking at things that I know that I couldn't get from the other side because they were occluded or on the bottom. So I'm concentrating kind of in this area, which is the bottom here. I don't know if you've probably noticed the bar on the left side there. This is showing my distance meter. Kind of the green is optimal, and you can scan up into the yellow on either side, but at some point you get far enough away that you don't scan at all, or too close that you don't scan at all. And that's one thing that I tell people when I'm doing trainings. I talk to them, or I tell them that the big thing with scanning is look at your object only to get yourself oriented in space, and then stare at your screen, because your screen is what is giving you your feedback, whether you're scanning or not. So I just glance at the object occasionally just to orient myself, because you can see, if I go right here, I see lasers. I see lasers all over this part, but I'm not scanning because I'm way too close. If I look out here, I see lasers on the part too, but I'm not doing anything. I'm not scanning. So your real feedback is the screen. So always watch that as you're scanning. One thing to note, you may have noticed I set the scanner down, I pressed stop, but I didn't touch the part initially, right now. The reason being is if I leave the part alone and I don't touch it, if I see something like, oh, I didn't do a very good job in this area, or I need a little bit more data here, I can, as long as I didn't touch that part relative to the table here, I can start right back into it. So I'll just do a little bit of that just to show you how that works. So you immediately see I didn't touch the part, so I'm fine. So I can go in and try to get maybe a little bit more of that wheel right there, or whatever I see that I missed. So that's something to think about. Always stop it let it run. It's running an optimization routine where it's kind of cleaning things up when I press done. That's what's happening here. So let that run and then have a look at your data. And if you need to add more, as long as you didn't touch it, just go ahead and start right back in and add more. So that looks fine to me. So we're going to do disconnected components. Okay, press delete. All right, now I'm going to come in here. Let me turn this plane off. And we're going to go ahead and splice these together. This. So I like to turn it on edge like this. And see, one neat thing with the lasso command, or lasso, is I get a straight edge. So if I click really close up here to this plane, that is the table, click here and then drag down. See, I have this nice straight edge right here that I can then tune to grab all those points all at one time without having to click on individual points. So it just makes it a lot more efficient. Click OK. That popped together over here. So merge is automatically selected. So as soon as I click this, it's going to merge those two scans together into one. And again, at this point, we're in point cloud data. So the step after this is to do what's called wrap, which wrap will make it into a polygonal mesh. So here is our merged point clouds. So now it's wrapping it into a polygonal mesh. While that's running, I'll talk about the next thing I'm going to do. So the barrel, you're going to find when you're doing 3D scanning, you're going to come up with like neat little tools and little devices that'll help you in your scanning ventures. This is just a simple vise, but it's been targeted. It's got soft jaws here. It's been targeted a lot. So, but it's a nice way to hold parts, but also utilize it as a target platform too. You can set this basically so it's basically in the middle of the part, or of the, the turntable. Then we've got the part here, my barrel. So the barrel has these two bars sticking out that actually are what hold the barrel into this thing. So I can take these and just stick them in here like this. So this will give me a nice stable platform to scan this with. And I'm kind of watching this here. I'm purposefully giving it a nice little air gap there, so it'll be very easy to cut anything away that's extra data that I don't need. So going back to this is the polygonal mesh of the carriage part here. So now we're going to move on to the last part, and that'll be the barrel. So add another scan. I'm checking my point density again. We want the same. And we're going to do a marker point scan. You probably noticed that with marker point scans, you can move very quickly. You just want to make sure you combine, pull in the other markers so that you see 4 at all times, old ones as you're pulling in new ones. So sometimes, this is very easy because I have a ton of markers, but sometimes you have to be careful with that. When you're going around a corner, for instance, you have to make sure you can bridge around that corner. So you may have to add markers outside a little bit to be able to bridge, like I said, bridge around there. When I'm doing a marker point scan, I can go quickly, but the main thing to focus on is just hitting them from a lot of different angles. Now this, we're going to try something here. It may not work, but we're going to try it anyway. I want to see, these aren't very planar, but let's see if we can interpolate a plane here. If not, we'll try it. Let's do a clipping plane. These are the ones on top of these soft jaws here. They're kind of canted a little, so this may not work. But the cool thing about this software is it'll tell you if you select targets that are out of plane and it can't make a plane. It doesn't just average them per se if they're far enough out of plane. So in this case, it took it just fine. So that's cool. So this will clip everything off from there down. Right. So now let's go back to here, and we're going to go to laser patch and start scanning. one really neat thing about this scanner is you don't have to worry about over scanning. What I mean by that is once it fills a certain number of points within a volume, it will stop collecting points within that volume. In other words, you can't stack data. You're not stacking data. Other types of scanners, if you keep going over the same area, you're actually stacking frame upon frame upon frame. So they become very large. So with this one, you don't have to be very concerned about that. You can't really over scan it per se. So that's another real advantage to this scanner. All right. That looks good. Stop. Okay, there's half of our barrel. Turn this plane off. We're going to do another one. So obviously I'm just going to flip this like this. We're almost done with our scanning of our components here. Okay. Vertical point, check that, good. Okay, let's see if our trick works again. This is like this plane. So that was really nice last time because we didn't have to delete anything with respect to the vise or table or anything. I'm just trying to be a little careful, make sure I get everything. Okay, here we go. Yes, that worked. Okay, cool. That's always exciting. Okay, here we go. So laser patch. Come in here, I'm gonna scan this very quickly. I'm using the plus button on I've got 4 buttons here. I'm using the plus one over here to scan in a bit, or to zoom in a bit so I can see what I'm doing a little better. Okay. There we go. All right. So now we're going to combine these. So this first one is your reference. Basically it's the one that's not going to move. So you're going to move what they call test. The test one moves to the reference. So you're setting which one is locked in space when you do that. And then this one is the one that's moving. So for this operation, I want to be down in this area. Again, I can just lasso select all the way across here, and I'm selecting all those simultaneously very quickly. And this is where it comes together over here. Click OK, and that's going to basically optimize that alignment and also merge them together into one point cloud. Then again, we're going to do a wrap. Cool. Okay, so now let's look and see what we have. We have the carriage in space over here. We have the barrel itself, and then we have the overall scan right here. Now somehow we need to align all this stuff up. So what we'll do is we'll start with the carriage. So I have the main scan open that has both the barrel and the carriage in it. And we can do align, and let's do endpoints, and I'm going to select the meshes here. So these two, that's what I'm working with. So I'm going to orient these in a logical fashion like this so that I can select common points. And that's my goal. And I want to select them in a way that they're not in the same plane. I want to be as random, really as random as possible with that. You know, look for little features like this little divot here. You'll see them pop together right in this area. Click OK. And now that, put those together there. So now we have this aligned in space. So I can take that, see, that's the overall, and then I've got it aligned there. So now let's do this one, and this is the last part here. We're going to align the barrel to the rest of this. Let's do endpoint alignment. And this time we're going to let's do this one here, and then the very last one, which is the barrel. There we go. Again, I'm orienting it so that it's a very similar orientation. So let's select different points here, some key points. Probably maybe the tip of the barrel here. You're just giving it, basically you're seeding this. In other words, you're giving it a good starting point. So maybe the back of this little knob thing here. Like that. So that looks like that's coming together well. So say OK. And there we go. So now if I get rid of this, and I could refine this further, but it's fitting fairly closely now. We've got, so turn the whole thing back on here. So now I've got this plus this in relatively the same space. So, or in the right orientation based on that first scan we did. So the point here is if you're doing something like an assembly, and you have several components that you're going to then be reverse engineering or doing other operations on, it's a good idea to go ahead and scan the overall assembly. Even if you scan it quickly and fairly roughly, scan the overall assembly, then take it apart, scan the individual components like this at a much higher resolution. Then use that first one you scanned of the overall assembly to align those individual parts back in space. So now when you export these to something like DesignX to reverse engineer, they're going to be oriented in space exactly where they belong relative to each other. And that's huge. So then you can align them in DesignX together as a system to the orientation, or to the DesignX's coordinate system. And it'll be, everything will line up perfectly. That's how you scan assemblies and then pull individual parts out and line everything up.